Hello, Assalamualaikum, and good morning to our lecturer Puan Fatimah binti Johan. So today we are from group number 5, excited to present our project for the digital electronic system for PBL assessment, which is regards the title is Smart Fire Alarm Activation System. Before we begin, let me introduce our team member. Me as a first representative, my name is Muhammad Ibrahim bin Muhammad Azani, and we have Muhammad Zulaiman, Muhammad Aikal, and Muhammad Abdullah Farah. In this presentation, we will talk about how we demonstrate digital logic gates to create a reliable multi-sensor fire alarm activation network. So let's dive into the core details. Let's go. So before we go deep into our this project, we have to tell about introduction first. So for the introduction, fire alarm provides early warning to protect lives and property. This system uses digital logic gates and 3 input sensors to detect fire accurately. So basically, we have 3 input sensors, which is smoke as S, heat as H, and flame as F. So these 3 input sensors work together to detect fire condition. So basically, when possible fire coming, so these 3 input sensors is detect fastly, quickly to detect. Okay. So when we have input, we have output also. Okay. So we have 2 output here. So for the output is alarm or buzzer SA and emergency light SE. So this output is activate when the fire is confirmed there. So these 2 output is activate. Okay. And the last one is digital logic. Digital logic we use AND and OR gates to process sensor input to produce reliable accurate outputs. So that's all.
Hi, Assalamualaikum. My name is Muhammad Abdullah Farah. Now I'm trying to explain you the problem that our project is trying to solve. So the question is, why single sensor system fails? So you know, in multiple sensors like traditional fire alarm system just can use only one single sensor. So the problem is that once one sensor is not always good, maybe it can cause the false alarm. So these are our examples. Number 1 is the smoke sensor alarm, number 2 is the heat sensor alarm, and number 3 is our last we put our solution. So number 1, smoke sensor maybe detect the cooking smoke, and also can make the rest even for or steam from the hot water, maybe oil water, whatever they hot. So this smoke sensor does not always mean there is a real fire. So number 2 is the heat sensor. So when the room become the hot, the heat sensor can be activated even if there is no fire. So this because maybe people ignore the alarm if rings too often mistaken. So last one is our solution. So our solution we put is saying the combining multiple sensor with logic gates and significantly reduce the false alarm. So our solution, we use the 3 sensors. Number 1 is the smoke sensor, number 2 heat sensor, and number 3 is flame sensor. So these sensors they work together, and the logic gates check all the signals before turning on alarms. So this system more portable and reduce false alarms. Also, it can help us to detect the real fire more accurate. So that's it.
So for my last part is I want to tell about system design. So for the system design, we have 3 inputs and 2 outputs. For the inputs, we have smoke sensor SS, heat sensor SH, and flame sensor SF. So for the 2 outputs is alarm or buzzer output and E, which is emergency light. So as we can see here, we have fire alarm system logic diagram, and we can see for the S input, we go to the AND gates, input AND gates, H input go to N input AND gates, and for the output AND gates, it goes to input OR gates. For the input OR gates, we have plus flame sensor. So which is for the output AND gates and the input flame sensor F combined together, we have two outputs, which is alarm and emergency light. So these 2 outputs is combination of output of smoke sensor and heat and plus flame sensor. Okay, so that's all from me.
Hi, Assalamualaikum. My name is Muhammad Aikal bin Afendi. So I will be presenting slide 5, 6 and 7, which cover the Boolean expression, the system input and outputs, the truth table for our smart fire alarm activation system. So now I will explain about the Boolean expression used in our system. Our system has 3 inputs, the smoke sensor, heat sensor and flame sensor. The output is the alarm and emergency light. The Boolean expression for our system is A equal F plus open bracket S multiply H close bracket. This means that the alarm will be activated if the flame sensor detect a flame, or when both the smoke sensor and heat sensor detect smoke and heat at the same time. So we use AND gate between the smoke sensor and heat sensor to reduce false alarm. For example, if only smoke or only heat is detected, the alarm will remain off. However, if the flame sensor detects a fire, the alarm will immediately turn on through the OR gate because it indicates a dangerous situation. So next, we move to the slide 6, system input and outputs. There are 3 inputs device in the system, which is first, the smoke sensor, which detect the presence of smoke. So second is the heat sensor, which detect high temperature. Third, the flame sensor, which detect the presence of fire or flame. So the output device are the alarm and the emergency light. So when the condition in the Boolean expression are satisfied, the output becomes logic high, which is means on, causing the alarm to sound and the emergency light to turn on as a warning to the user. Okay, next, let's we move to the slide 7, which is present the truth table for our system. The truth table shows all possible combination of the 3 inputs and the corresponding output. Since there are 3 input, there are 2 power of 3 or 8 possible input combination. From the table, we can see that the output becomes logic 1 whenever the flame sensor detects a flame, or when both the smoke sensor and heat sensor are active at the same time. If these conditions are not met, the output remains logic 0, which means the alarm and emergency light stay off. The truth table confirms that our circuit operates exactly according to the Boolean expression that we discussed in the previous slide. So that's all from me. Thank you, and I will now pass the presentation to the next presenter.
Okay, for my part, I will explain the logic gate circuit and the simulation result. In this case, we use 3 inputs. S is for smoke sensor, H is for heat sensor, and F is for flame sensor. The smoke sensor and heat sensor are connected to the AND gate. So the AND gate will only give logic 1 when both smoke and heat are active together. After that, the output from the AND gate and goes to the OR gate. The flame sensor also goes directly to the OR gate. This means if flame is detected, the system can turn on. The system can turn on immediately. But if there is no flame, the system will only turn on when smoke and heat are detected together. The output from the OR gate is connected to both the alarm and the emergency light. That is why both output turn on at the same time. Okay, for the test case 1, S, H, and F are all in 0. This means there is no smoke, no heat, and no flame. So the AND gate output is 0. The OR gate output is also 0. Because of that, the alarm and emergency light is stay off. For the test case 2, S is 0, H is 0, and F is 1. This means only the flame sensor is active. Since the flame sensor is connected directly to the OR gate, the output becomes a logic 1. So both the alarm and emergency light turn on. This test case shows that the flame detection can active the system immediately. For the test case 7, S is 1, H is 1, and F is 0. This means smoke and heat are detected, but flame is not detected. Since both S and H are 1, the AND gate output become logic 1. Then the OR gate also give logic 1. So the alarm and emergency light is turned on. Okay, for the test case 8, all inputs are become 1. So smoke, heat, and flame are all in detect. In this condition, the output is also logic 1. So both warning outputs turn on. This shows that the circuit works correctly when smoke and heat are active together, but also when flame is detected. Okay, for this table shows that simulation result for all 8 test cases. We have compared the expected output with the actual output from Multisim. From the table, all results are matched. This means the actual output is the same as the expected output for every test case. The alarm stay off when there is no flame and when smoke and heat are not active together. But the alarm turn on when flame is detected or when smoke and heat are detected at the same time. So, from this simulation result is matched the truth table and follow the Boolean expression correctly. The Boolean expression is A equals to F plus S and H and E equal to F plus S and H. So, overall, the circuit worked as expected.
Okay, now we'll continue our presentation. So this is our last conclusion. We have here 5 boxes. So box 1 is saying the logic gate usage. So the system successfully sent when using the AND gate and OR gate. So our system uses the 2 gates, AND gate and OR gate. So these 2 logic gates control when alarm should turn on. So next is the box 2 Boolean verified. So our Boolean expression is A equal F plus S and H. So that means the system follows the correct logic gate when we design it. So box 3 is false alarm reduced. So that means our system reduce false alarm like smoke must be detected together before alarm turn on. So that means one sensor is not enough it. So box 4 is talking the flame priority. So this next point is flame priority. So if flame sensor detect fire alarm and immediately this light turn on, so it's making immediately because the flame is not too strong in real life. So lastly is our box 5 is talking the simulation confirmed. So all 8 test case. So we tested all 8 tests in using Multisim application. So we matched the truth table. Then the standard is fully validated. Means our system works correctly. So that's it. Thank you very much for your listening, for your attention, and we hope you enjoy it. Thank you very much.